Look at this class. It's noisy, isn't it? Compare it to this record type. What's the difference? There are a couple of differences. The most dramatic difference is that the class implements reference equality while the record implements value-typed equality. Both are reference types though. The keyword record is just shorthand for record class. Oppose that to a record struct. Oh, if I continued at this pace, you might start hearing strange voices. Let's focus on one question at a time, and we will gradually come to realize how record types have changed how we do the programming in C#. Reference equality means that the two instances of this class at the top are equal only if their references are equal. If I added an instance to a hash set and then immediately tried to find an obviously equal item, the hash set would readily testify it doesn't contain such a thing. Repeat the same exercise with a record and the hash set will change its mind this time. The difference is that the compiler will generate equality members in every record type, whereas it will not do so in a class. Should I add these members myself? That would surely increase the noise this class produces, but that is a lesser issue. I'm creating two distinct instances of the improved class. One I plan to add to the hash set and the other will be the search key. The answer will finally turn to true, which is the right answer. Unless I make the two objects equal after adding one to the data structure. The hash set will not find the key, even though it contains an equal object. This is a complete mess. The class is inflated and wrong. And to add insult to injury, it is slower than the alternative. The record struct does everything the record class does, ensuring that you can use it both as a value and as a key, plus acts as a value type, reducing allocations. 3 fundamental benefits in one line of code. That is the holy grail of programming. Write short, fast, and correct code in one sweep. That is the point at which record types started to bend the entire programming culture in .NET and C#. First, property setters and, by the same token, any immutators don't belong in a class with equality member overrides. You can only compare mutable objects by reference. Otherwise, remove the setters. I will now give you a puzzle to think about. This class modeling a ticker is screaming immutability. There's absolutely no difference between a stock exchange ticker and an integer value. While you would never think of integers as mutable objects, I still need to persuade people to remove property setters from classes like this one. How come? And here is the puzzle. Without even knowing what project you are working on, I will guess that at least 80% of all types you made in it are screaming immutability. I dare you to tell me I'm wrong. That is a fact of life. We live in a world of values, not entities. Entities are rare animals. They are heavy. They cost in every possible way. You know an entity when you see one. This ticker is not one. And then the records syntax came to clean the mess. It became apparent that the regular classes were noisy. Why all this? Come on! How can a record use what they call a primary constructor and I cannot use it myself? Now I can. Define the primary constructor and list what they call class parameters. If you plan no validation, then you can use class parameters directly in members. This approach is useful when receiving objects as parameters. They must have already passed validation, leaving nothing to check here. In this example, I cannot escape it because I need these values for comparison. That is the second giant impact record types made on us. The first impact was that we suddenly began to view immutability more explicitly, more consciously than in the past. The second impact is that now we claim short definition of classes. No more curly braces terror. If my friend can write a record in one line, I want to write a class in no more than 3. Short class definitions became a human right. You will now notice that immutability prevents the object from being inadvertently changed after creation. The entire confusion is now impossible. The equal object is not present in the hash set, and it never was. This class is now becoming an obvious candidate for a record. It used to scream immutability. Now it screams I'm a record. But what if it is not a record? That would change the situation from its roots. That tells me that the class should not implement value-typed equality. Equality checking remains the only difference between an immutable class and a record. So either make it a record or delete the equality member overrides. That done, remove the properties unless you need to expose them for some other purposes. You can always use class parameters in immutable transforms. The class is so wonderfully short now, and it does more than it did while it was a dozen lines of code long. This screen shows the ultimate division of types in C# today. The first category consists of entities, which I haven't even used here. An entity would consist of other entities and values. It would typically expose heavyweight, mutable operations. It would also come with an identity more often than not. You will want to persist instances of this class and reconstruct them in a later operation. Then come the immutable classes that still do not support value-typed semantics. Use shorthand syntax as much as you can when writing those. Then come the reference types with value-typed semantics. Use records for those. Let the compiler generate dozens of lines of code for you. The last category is the proper value types. In classes, when you need many small objects of this kind, you can improve performance by using record structs. Do not use traditional structs anymore. They rely on reflection for equality comparison. Record structs come with compiler-generated equality members. That makes them as fast as one can get. This is the new C#. This screen speaks the story of how we learned to design types that clearly communicate the intention. I could speculate that the appearance of record types has caused this change, but that wave of changes started even before them. I will show you one aspect of C# which many programmers have ignored altogether, for reasons I cannot understand. Before that, let me mention my Patreon page. This channel is free thanks to the growing community of patrons who support it. If you like what you have learned, please consider joining this community by becoming a sponsor. Every patron has access to the source code for all the videos on my channel, as well as to the additional materials that are not available on YouTube. You can find the link to my Patreon page in the description. The last thing I wish to explain in this video regards value tuples. Long before record types, we got a performant implementation of tuples and tuple literals. Just like record structs, there were the value types with value-typed semantics built in by the compiler. You can use value tuples in all places where an equatable value is expected, such as in hash sets and dictionary keys. You could name the fields of a value tuple for convenience, but that was just an illusion, a compiler trick. It is funny that the compiler will tell me that something strange is happening in this assignment, but it won't go any further than just displaying a warning. If I did it this way, the compiler would remain silent, though I have just mixed apples and oranges. While value tuples were fast and convenient, they significantly reduced the strong typing constraints. At the same time, they also significantly reduced the sheer size of our code. From this time distance, I would argue that record classes and record structs came to bring back balance to the force. Unlike value tuples, I cannot assign one record type to another just because their components are of the same type. I would now like to hear from you. Are you applying the new pieces of syntax, and what is your motivation to do or not do that? Is your new C# code shorter today than it used to be a couple of years back?